Factoring the polynomial p of x equals a sub n x to the nth power plus a sub n minus 1 x to the n minus 1 plus, and that pattern continues, plus a sub 1 x plus a sub 0 can be challenging, especially when both a sub n and a sub 0 have many factors. Consider the equivalent equations 24x cubed minus 22x squared minus 5x plus 6 equals 0, and the product of three binomials, first x plus 1/2, then x minus 2/3, finally x minus 3/4 equals 0, which both have negative 1/2, 2/3, and 3/4 as roots. The numerators 1, 2, and 3 are all factors of the constant term 6. The denominators 2, 3, and 4 are all factors of the leading coefficient 24. One way to find a root of the polynomial equation p of x equals 0 is to guess and check. This is inefficient unless there's a way to minimize the number of guesses or possible roots. The rational root theorem uses both the constant term and the leading coefficient of a polynomial to limit the possible rational roots of the related polynomial equation. Take note, rational root theorem. Let p of x equal a polynomial a sub n x to the nth power plus a sub n minus 1 x to the nth minus 1 power plus, and that pattern continues, a sub 1 times x plus a sub 0, a constant, be a polynomial with integer coefficients. There are a limited number of possible roots of p of x equals 0. First, integer roots must be factors of a sub 0, the constant. Rational roots must have reduced form p over q, where p is an integer factor of a sub 0, the constant, and q is an integer factor of a sub n, the leading coefficient. Consider this example. 24x cubed minus 22x squared minus 5x plus 6 equals 0. 24 is the leading coefficient. 6 is the constant term. The rational root theorem tells us we can use the factors of the leading coefficient and the constant term to list all possible rational roots. Problem 1. Finding a rational root. What are the rational roots of 2x cubed minus x squared plus 2x plus 5 equals 0? The only possible rational roots have the form the numerator, a factor of the constant term, for us that's 5, over the denominator, factors of the leading coefficient, in this case that's 2. The constant is prime, so its factors are plus or minus 1 and plus or minus 5. The leading coefficient is also prime. Its factors are plus or minus 1 and plus or minus 2. The only possible rational roots are plus or minus 1, plus or minus 5, plus or minus 1/2, and plus or minus 5/2. Note these are all the possible combinations of fractions with numerators, which are factors of the constant, and denominators, factors of the leading coefficient. The table shows the values of the function y equals p of x for the possible roots. Note our top row, x, 1, negative 1, 5, negative 5, 1/2, negative 1/2, 5/2, negative 5/2. And our second row, the outputs for the function p of x, evaluated for the inputs x above, 8, 0, 240, negative 280, 6, 7/2, 35, and negative 75 over 2. The only rational root of 2x cubed minus x squared plus 2x plus 5 equals 0 is negative 1. Your turn. What are the rational roots of 3x cubed plus 7x squared plus 6x minus 8 equals 0?